Divisibility rules. So today we are going to talk about the divisibility rules for 2, 3, 4, 5, 6, 7, 8, 9, and 10. The ability to be divided with no remainder is what I mean when I talk about divisibility. So if I take a large number and divide it by 2 and I get a quotient with no remainder, then we know that original dividend is divisible by 2. So that's what we mean by divisibility rules, the ability to be divided with no remainder. The first rule that I believe you are all pretty confident with is the rule of 10. So when we look at a number, if the last digit ends in a 0, then the number will be evenly divisible by 10. And we could talk about a really, really large number, or we can talk about something smaller. So for example, if I have 4,670, we know because there is a 0 in the ones place, then this entire number is divisible by 10. Moving on to our next favorite divisibility rule, the rule of 5. So similar to the rule of 10, we're looking in the ones place, and if the last digit is a 0 or a 5, then the number is evenly divisible by 5. So, for example, if I had 16,855, in our ones place, we have a 5, so this entire number is divisible by 5. When I go ahead and divide by 5, I will have no remainder. The rule of 2 is also a very well-known one, and I'm sure you all remember it, is we're looking for even numbers. So if the number ends in a 0, 2, 4, 6, or 8, we can divide that entire number by 2. So looking for our even numbers. Now 3 is a pretty awesome rule. It doesn't really matter how many digits we have. All we have to do is add up the digits. So find the sum of all the digits and see if it's a multiple of 3. So here I have some examples. 2051. So what I did here is I'm going to add up all the digits. 2 plus 0 plus 5 plus 2. 2 plus 0 plus 5 plus 2. When I add them all up, I get a sum of 9. We know 9 is a multiple of 3. We know 9 is divisible by 3. So that means this entire number is divisible by 3. So here's another example. 4,103. 4 plus 1 plus 0 plus 3. That gives me 8. 8 is not a multiple of 3. You can't divide 8 by 3. So this entire number is not divisible by 3. Now, the explanation for why this rule works can get a little bit complicated. I will post a video from Khan Academy on why this works. It has to do with the concept of powers of 10, and you can watch that video if you want a further proof of why does this work. And as we know, the rule of 9 is very similar, so it's the same proof. The rule of 6. So in order for a number to be divisible by 6, we're checking, is it even? So is it divisible by 2? And is it divisible by 3? So if it's divisible by both, if it checks both of those boxes, then it will be divisible by 6. So make sure you're checking for both, checking that it's even, and then adding up the digits to see if it's divisible by 3. The rule of 4 can be somewhat helpful when I'm looking at the last 2 digits. So I'm looking at my tens place and my ones place. I can check if those 2 numbers are divisible by 4. So for example, I have 240, and I want to know, is 240 divisible by 4? So instead of me dividing the entire number by 4, all I have to do is look at my last 2 digits of 40. So we know that 40 is divisible by 4 because 4 times 10 gives us 40. So that will work out nicely. So that means 240 is also divisible by 4. So I'm just checking for the last 2 digits. So if I was given a number all the way to the thousands, hundred thousands, all I have to do is check my last 2 digits and check if it's divisible by 4. So here's an example of how it will not work. 375, I have no idea if it's divisible by 4, so I'm going to check the last 2 digits. 4 does not go into 75 evenly. If I need to go off on the side of my page and divide, that's a-okay. And unfortunately, that means 375 is not divisible by 4. The rule of 7. Now, I know many of you probably have not learned a rule for 7, but I have discovered one and I love using it and I think it's actually quite fun. So I'm going to slow down on this rule because I know many of you have not seen it. What you want to do is double the last digit and subtract that solution from the remaining digits. If the difference is a multiple of 7, the number is evenly divisible by 7. So I have an example here of 672, and I'm going to go off to the side of my page to do this. So I have 672. And what it asked me to do is double the last digit and subtract that from the remaining digits. So what I'm going to do is I'm going to look at my number 2, right? So I'm going to put a box around it because I'm not going to need it anymore. All I need to know is that I need to double it. So 2 doubled, or 2 times 2 gives me 4. So I'm going to put the 4 right underneath my 7 over here. And now I'm done with the 2, so I could cross it off. And I subtract. So I know that 7 minus 4 is 3. And I'm going to bring the 6 down. Now, in this situation, I know that 63 is divisible by 7, so this entire number is divisible by 7. If I wasn't sure, I can continue on. So I can box out my 3, double it, so 3 times 2 is 6, minus 6 is 0. So if we get to 0, that's an awesome thing because 0 is divisible by 7. When I divide 0 by 7, I get 0, no remainder. So 672 is divisible by 7. I'm going to give you a different example because this will apply to all sorts of numbers. Over here it says applying this rules to numbers with more than 3 digits can be complicated. However, if your number has more than 3 digits, you just continue the process, repeat the process. So just like I repeated the process here, if you were unsure if 63 was a multiple of 7, I kept going. So you can keep going if you get negative 7, that's divisible by 7. If you end up with 14 or 21, we know that's divisible by 7. So I'm going to give you an example so we can practice this again. So let's do a larger number. So let's do 1,792. And I want to know, is this number divisible by 7? I'm not sure, so let's check it out using the method. So I'm going to take a look at 2. And again, I want to double that, so 2 times 2 is 4. So I'm going to put a 4 down here to subtract from the remaining digits. I'm done with this too. So now I can subtract. I have 9 minus 4 is 5. Bring down my 7, bring down my 1. Now, I can keep going. We may not know if 175 is divisible by 7, so let's keep going to see if this is going to work. I have 5, so I need to double that. 5 times 2 is 10, so I'm going to subtract 10 from the remaining digits and bring down my 7. Because 17 minus 10 is 7. We ended with a 7. We know 7 is divisible by 7, so that means this entire number, 1,792, is divisible by 7. Let's do another one just for fun. Let's do one that doesn't end so pretty. Let's do 2,500. Let me write in a different spot. I'll write over here. 2,576. Let's see if that's divisible by 7. So checking again, I want to double my last digit. That gives me 12. Subtract that from my remaining digits. 7 minus 2 is 5. 5 minus 1 is 4. And bring down my 2. Still not sure? Gonna keep going. 5 times 2 is 10. Subtract from the remaining digits. Subtract. Now I ended with 14. We love that. So we know 14 is a multiple of 7, so that means this entire number is divisible by 7. But let's say I wasn't sure. I had no idea that 14 was a multiple of 7. I could keep going. So in this case, I can double this. I would end up with 8. Now 1 minus 8 is a negative 7. Now hopefully you knew 14 was a multiple of 7, but if you weren't sure, we end up with negative 7. Negative 7 is definitely divisible by 7, so I see a 7 there. I know I'm good. I love this rule. It's different. It's definitely new for many of you, so practice it. Moving on to the rule of 8. I don't love the rule of 8, but it's there for us So similar to the rule of 4, you're looking at the last 3 digits instead of the last 2 to see it's divisible by 8. So if you have lovely, lovely numbers like 7,016, it's noticeable that 16 is divisible by 8, so this whole number is divisible by 8. Where in this situation, we have 6,473. I'm going to have to divide and see. So instead of dividing 6,473, all I have to do is divide 473 to see if I get a quotient with no remainder. But unfortunately, in this situation, you get a quotient of 2, but you have a remainder of 7. So in this situation, it's not divisible by 8. So yes, there is some division required, but if you were dealing with a number in the millions, at least you're not dividing that huge, huge number. You're just looking at the last 3 place values. Last but not least, our rule of 9. So similar to the rule of 3, we're doing the exact same thing. We want to add up our digits to see if it's divisible by 9. So 2 plus 3 plus 7 plus 6, that gives us 18. 18 we know is divisible by 9 because 18 divided by 9 is 2. So this entire number is divisible by 9.